Lesson 10.2, Angles in Radian Measure. Angles in standard position. So we're not talking about triangles now, we're just talking about angles. If you put an angle on a graph, you put its vertex on the origin. The initial side is on the positive x-axis, so that's our initial side there. And it's measured counterclockwise. And then the terminal side is wherever. And so you see where this red arrow, arced arrow is, that's the angle. Coterminal angles are angles with the same measure that have, different measures that have the same terminal side. So they're different angles, but the same sides. Here's some examples. So the blue one is negative 45 degrees. It's negative because they went clockwise. But maybe we could start and go counterclockwise, then it's 315. Or maybe if we start and we go clockwise all the way around is 360. And then the 45 more makes it negative 405. Or we could go around and around and around. Say, oh, but wait, that's the same angle. Well, I don't know. Ask a skateboarder or snowboarder. Is doing a 360 the same as doing a 720? Or the same as doing a, was it 1080? No, they're different. The number of times you go around are different. So these coterminal angles are different. And as you might notice, it's by going all the way around the circle, which is 360 degrees. So they can be found by adding or subtracting multiples of 360 degrees. So let's draw an angle with a given measure in standard position. Then find one positive coterminal angle and one negative coterminal angle. So let's start with 65 degrees. All right, well, if this is 0, by the way, the positive x-axis is always 0. That's 90, 180, 270, and we're back to 360. 65 is between 0 and 90, and it's closer to the 90. So it's probably, terminal side would be about there. So that would be about 65 degrees. All right, now let's find the coterminal angles. Well, we can add or subtract 360. So we could go plus 360 would give me 425. So that's going all the way around and to there. Or we could subtract 360 and get negative 295. So that's here going backwards. But it ends at the same point. Shall we try another? All right, let me clear the markings. All right, so 300 degrees. Again, this is 0. This is 90, 180, 270, and 360. So 300 degrees is between 270 and 360. So maybe about right there. So that would be actually starting and going this way around. To find the coterminal angles, we could add 360, which would give 660. So that's going all the way around and then around to our angle. Or we could subtract 360. Because it's negative 60. It should just be that way. Since it's negative, I can go clockwise. But they all start at the x-axis. They all end at the same terminal side. Sometimes you might have to add a couple times or subtract a couple times. I mean, if, let's say you tried this one, adding 360 is still going to be a negative angle. So you'll have to add 360 a couple times to end up at a positive angle. So why don't you pause this and try number 3, which should give you negative 900, and number 7, which should give you the 900 and the negative 125. The positive here is 180. The negative could be negative 180 or negative 540. The other one, the positive, is 235, and the negative is negative 485. Another unit to measure angles, other than degrees, is radians. So radians is just a unit, just like inches and centimeters are different units that measure the same thing. Radians and degrees both measure the size of an angle. So it's another unit to measure angles. 1 radian is the angle when the arc length equals the radius. So there's a circle. That's the radius. So there's the arc length. That's the same length as the radius. So that is 1 radian. That is the size of 1 radian. So in half a circle, there are pi radians. And in the full circle are 2 pi radians. So there's 2 pi radians in a complete circle. To convert between degrees and radians, use the fact that 180 degrees equals pi radians. All right, so how do you tell the difference between if it's degrees and radians? Now, a lot of people are going to say, oh, well, if it's in pi, it's in radians. No, that's not true. If it has a degree symbol, then it's in degrees. If there is no degree symbol, then it's in radians. So there's no degree symbol on the pi, therefore you know it's in radians. Pi is a number, not a unit. There are a bunch of special angles. Wow, look at all those angles. In both degrees and radians. So 30 degrees is the same as pi over 6 radians. All right, so radians uses fractions of pi because pi is all the way across the circle, right? So halfway across is half of pi. Or here's 1/6 of a circle, 2/6, which is a third, 3/6, which is a half, 4/6, which is 2/3, 5/6, and then 6/6, which is pi, so that's half a circle. And you can keep counting by 6. Quarters of the half of the circle is pi over 4, and then that's 2 pi over 4, which is pi over 2, 3 pi over 4, and then 4 pi over 4. And you can keep counting. So it just goes by fractions like that. You need to memorize the circle, expect a quiz on it. There is symmetry, so if the symmetry you can figure out just the first quadrant, you should be able to get the rest. Try to find the patterns. It's just counting by sixes, six or quarters, or 30s and 45 degrees. All right, let's convert the following degree measures to radians, or the radian measure to degrees. So 135 degrees. Let's convert that to radians. We're going to use the fact that pi radians is the same as 180 degrees. Going to put the 180 degrees on the bottom so the unit cancels out. Pi goes on top. So it'd be 135 pi over 180, but we can reduce that by 45s, which gives us 3 pi over 4 radians. If there's no unit, then it's radians. Let's try negative 50 degrees. Okay, I'm putting the 180 on the bottom so that the degree cancels out. The pi goes on top. So that'd be negative 50 pi over 180, which we can reduce by 10. So it's negative 5 pi over 18. Let's try some going the other direction. This one's in radians. How do I know it's in radians? Because there's no degree symbol. Okay, I'm going to put the pi on the bottom so it cancels out. The degree on top, that way I end up with degrees at the end. So I have 5 times 180 divided by 4. It's actually probably easier if we divide by the 4 first. 180 divided by 4 is 45. And 5 times 45 is 225. Now, this one and this one, we could have gotten off that circle that we just had. Why don't you pause this and try number 40 from your homework. You should get 2 pi over 9. Radians make finding some things that we found in geometry with circles much easier, mainly arc lengths and areas of sectors. A sector is a slice of a circle, like a piece of pie or a piece of pizza, whatever. If you're thinking pizza, arc length would be the crust. How long is the crust? Remember, in geometry, when we're using degrees, we had to take the degrees, divide it by 360, and then do some multiplying by the circumference. And, well, if I use radians, it's really easy. Arc length is the radius times the angle. But the angle has to be in radians. The area of the sector is 1/2 the radius squared times the angle. But again, the angle must be in radians. It's a much simpler formulas than we had in geometry. All right, so here's a baseball field. Let's find the length of the outfield fence if it's 220 feet from home plate. Well, the outfield fence would be the arc length. Okay, so arc length is r times theta. All right, well, that's easy enough. R is 220 feet. What's my angle? 90 degrees. Oh, wait. It can't be in degrees. It has to be in radians. So it's pi over 2. Which make 110 pi feet, or approximately 346 feet. Well, how about the area of the ball field? Well, that's a sector, so the area is 1/2 the radius squared times theta. So it's 1/2 220 feet squared times my angle, make sure it's still in radians, which gives us 12100 pi feet squared. I'll run that through your calculator and you get 38013 approximately square feet. Why don't you pause this and try number 29. Find the drone search area. All right, it's an area, so you're going to use the area formula. Make sure you change the degrees to radians, and your final answer should be 1.53 square miles.